Hello students, myself Shubham Saugule, and today we are going to discuss about displacement sensors, position sensors and proximity sensors. So what are those? First we will start with the displacement sensor. Now this is the sensors where we can check we can measure the displacement of any object. If you are standing here and you want to measure a distance of a particular object, you can use a displacement sensor and you can check the distance or the position where that sensor is present. Or one more thing, if you are standing here and one object is getting displaced by this point to this point, so what is the initial point and what is the final point? By that thing you can check the displacement of that object by using the displacement sensor. Now when we go for the position sensor, this sensor is used to measure the position, means two objects are there or you are standing at one place and another object is placed at some place. Then if you want to check the distance between you and that object, you can use the position sensor. This sensor is used to measure the position. So we can call it as position sensor. Now we come to the next proximity sensor. Now this is the one type of position sensor itself, but here one certain limit is there so that you can measure a position of any object within that range. For example, this is your mobile and near your speaker there are some sensors like this. Okay, so when you come near to your mobile while calling someone, that screen will get off like this, the side view of that mobile, and somewhere here near to that speaker one sensor is placed, that is called as proximity sensor, and that proximity sensor is having some range, and when you call someone, that proximity sensor get activated. Now when you take your face near to your mobile, what will happen? Screen will get off, and this is happen within some range. If you are taking your hand on this point, mobile screen will not get off, but if you are taking your hand near to this point or near that range or within that range, that time the screen will get off. This is how proximity sensor works. Now which factor have to consider while selecting particular type of sensor? There are different factors we have to consider. First one is size of displacement. Depending upon the size of displacement, we have to consider different sensors. If size is very long, then we have to use a higher grade sensor to measure the long distance. Next is whether the displacement is linear or angular, angular. Linear, if the linear distance is there are different sensors are used to measure those. If the displacement is angular, we have to use different type of sensor to measure that. So depending upon the linear or angular displacement, we have to select the sensors. Next is resolution required. What resolution you require, that type of sensor we have to use. Next is accuracy. What type of accuracy you require? By that you can choose the sensor. And last is cost. Now we'll see types of displacement and position sensors. First one we categorize is contact sensor, and second one is non-contact sensor. Now in contact sensor, there will be physical contact between the sensor and object to be measured, and in non-contact there is no physical contact between object and sensor. Now we will see displacement sensor, different types of sensor and how they works. Now first one will come to the potentiometer sensor. The potentiometer consists of a resistance element with sliding contact which can be moved over the length of resistance element. This can be used for linear, angular displacement measurements, the displacement being converted into potential difference. Now here you can see the potentiometer sensor. Now what is happen here, there are two terminals. This one is the first point and 3 is last point. Now in between that, the 2.2 can be slide. If you rotate this, it can move from here to here. Now what will happen while moving this or while sliding this varies the potential difference. Means what? If you come here, the resistance will be very less. If you go far from the first point to it, near to third point, this, if you can see here, this is the sliding contact, and if you near to the first point, there will be very less resistance. And if you come very far from that point, if you slide from that point, what will happen? The resistance will get increased, and this gives you the potential difference. And by that potential difference, you can identify how much distance you have traveled. By this circuit, we can understand this equation, that is V naught or V out by Vs, this is sliding, and R23 by R13. Here you can see the resistance between point 2 to 3, and R13 is resistance between point 1 to 3. Now this type of sensor is used to measure angular displacement as well as linear displacement. Now next we will see strain gauge element. Now this type of sensor or strain gauges are used for measuring the strain. What is strain? If this is the body and if you apply a load on that, what will happen? If this is the initial length, it will get elongated by delta L. If the original length is L, it will get elongated by delta L. That is, we can call it a change in length. Now what is strain? Change in length by original length. This is called as a strain. Now to measure such things, what we use? We can use strain gauge element. Now how it works? It is very small thin wire which is placed like this. Very thin means how much thin it is? You can print on a object like that. It is very like that. It is thin. Means how you put a stamp on a paper. Like that only this wire can be printed over any object where you want to measure the strain. That much thin wire we have to use, and it is placed like this. And these are the connection lead where you can give the current supply. Now how it works? If there is one curved beam like this, it having some thickness, and it is fixed at the bottom, and if you put some load over here, is it able to measure the strain obtaining strain creating in this beam? No. By calculation we cannot find that strain. So such times or such object are connected with the strain gauges. Over here we can put a strain gauge and we can give the connection to that, and from this we can measure the strain strain creating on that element. Now how we can measure the strain? The resistance, change in resistance to the original resistance. By this we can check the strain. Now what is original resistance and what is change in resistance? If a body is placed without applying any load, and if you put the strain gauge over here, it having some resistance that we can measure, or we can measure by applying the current. Now if you apply some load on that body, what will happen? The resistance, obviously resistance will get changed. Why? Because it will get separated by their original positions. If you apply a load like this over here, that strain gauge, what will happen? This will get separated. Now when it is getting separated, that time the resistance also will get changed, and that resistance we can observe here. Now when we observe that change in resistance, we can take that change in resistance and we can divide that by original resistance. We can get the strain obtained or strain created in that body. This is how strain gauge works. Now on what kind of part we can use? The normal like this, or curved beam like this, or circular bodies like this. If you are putting a load over here, then we can place strain gauges over here. So that maximum strain creating in that body, that we can measure. If a body is like this, you have to understand where the maximum strain may get created, there you can put this strain gauges. Now in such body, if the load is applied on this point, then you can place your strain gauges here so that you can measure the maximum strain created in that body. If a straight bar is there and beam is there, and if you applied a load over here, where we can put strain gauges here, so that we can get strain created in that body.